So how are inequalities viewed in the world? Be sure you have the date. The topic is inequalities, by the way. So you have a little topic spot, linear inequalities, if you didn't have that down from before, linear inequalities. All right, so first example. I want you to read through and try to see what might be important. Let's try to figure out what the variable will be. Maybe there's one variable, maybe there's two variables. What are we looking at? So suppose you intend to spend so much money. How many pounds of each can you buy? So we're talking about pounds of the peanuts, pounds of the cashews. So X being the number of pounds of peanuts, Y will be the pounds of cashews. So in the relate portion, this is where we set it up in words. So putting all of this together, it says $2 per pound. So if we can take the cost times the number of pounds, so this is going to be like last semester. So cost per pound of peanuts, but the second piece was not a fraction. It was times the number of pounds of peanuts. And I want to stress, some of you have been putting fractions for both sets of parentheses, but that is not the case. The first one is a fraction because it deals with two nouns, dollars per pound. All right, so we have cost per pound times the number of pounds, and we're going to add that to cost per pound of cashews times the number of pounds of cashews. This is going to equal the total. Wait a second. I'm going to put a little question mark in a circle because we're going to talk about this. It's actually not equal to 12 anymore. Oh, wait. It's not actually equal to the total cost anymore. So I'll put 12 in the right, WRITE position. We've got to figure out where that's at. If you have a color, use a color here. Now that you've got your color, I want you to highlight the key word or the key phrase, no more than. So this right here, whether you highlight it, box it, or whatever, I need it to stand out because it does not say exactly. It says no more than. So that means what would be an appropriate amount if I want to spend no more than $12? $11.99. $6, $7. So think about how those numbers, so like if you are $11.99, how is that going to be compared to 12 using a symbol? It'd be less than. Is it equal to? Is the question. So if I spend $12, is that no more than 12?
No. Yes.
Well, it's not more than 12 because 12 is the border. So this is actually an example of less than and equal to. So using your color, what I want you to do is using that same color that you highlighted this in, I want you to put less than and equal to because it's no more than. All right, so the previous stage, dollars per pound of peanuts, we can literally find in the problem. So it's going to be 2 in that spot. Number of pounds of peanuts, if I go back up to my defining position, that was represented with an X. Dollars per pound of cashews. So a pound of cashews is 4. And number of pounds of cashews was represented as my Y. We have that symbol, notice how I'm using my color, less than or equal to the total cost, which we already talked about was 12, because we're going to spend no more than 12. So here we go. Here's how we graph it. Or, do you remember how we graph it? What we used to do with an equal sign was, okay, x-intercept, that's a number, comma, 0. So you put a 0 in for the y. And it basically gets this piece away. And what's the x-intercept? So you would take 2x equal to 12.
6.
So the x-intercept would have to be 6. So we're going to graph a point at 6, 0. Then you'd look at the y-intercept. And the y-intercept means you have 0 comma number. So put a 0 in for the x and it wipes out this term. We're left with 4y equals 12. So the y-intercept is 3. So now it's an expectation that you, last semester, have grown accustomed to that strategy. We're going to graph those points on this, but we need to label it. Since I'm dealing with a word problem, we need to label it. So we defined our x-axis, or our x, what was it? Pounds of which one? What was our x?
Peanuts.
Okay, thank you. Pounds of peanuts versus pounds of cashews. And then I believe because our x and our y intercepts will both fit if we just have these as ones, like 1, 2, 3, 4, 5, 6. I believe we have enough room for it. So I'm going to graph both. I want to highlight what you guys said. Some of you said, well, if I have 6, so notice how I'm putting that in color. If I have 6 peanuts and no cashews, I'm still okay with my amount. Some of you said, well, if I have no peanuts but 3 pounds of cashews, I'm okay. Now what was it? 2 and 2. That's what you came up with. 2 and 2. Notice how 2, 2 is also on the boundary. What else is on the boundary? So when I gave the suggestion that 1, 1 also works, that means 2, 1 also works. If we had 2 pounds of peanuts and 1 pound of cashews, we're still less than $12. If I have 3 pounds of peanuts, 1 pound of cashew, we're still less than $12 in our budget. So when we have these inequalities, we have to realize, like, how do we show all of the possibilities? So here's what happens. Take your color, and the way we show all the possibilities is we sort of create a triangle where anything in this realm is actually appropriate. Okay, now it's making sense. My graph was off. Whoopsies. I had this at 7 and now it's at 6. Oh, so now it's perfect. Okay. Yeah, all those points. Great. And then we talked about 1, 1, but we still are going to be shading all these. Thank you for pointing that out. Appreciate it. So let's read through this. Let's define new variables, underline, and see if we can come up with, come up with an inequality. Reading this problem, trying to figure out what are we going to define. I notice we're talking about shirts and pants. So, and I shouldn't use that color. Let me make sure I stay. So, X is going to equal the number of shirts. Y is going to equal the number of pants. Once we have the defined piece, then we're going to have cost times number plus cost times number. And then we're going to have to figure out, well, how is this related to the total budget or the total cost? So when we talk about budgets, the question is, yeah, we're going to have to be less than that, but then again, can we equal 200? If you have a budget of so many dollars, does that mean you have that exact amount of dollars to spend? This is going to be less than and equal to. When you have the word budget, you can go less than or equal to, but you can't go any more above. So when we write the cost per shirt, we can actually find that. The cost per shirt is $25 each. Number of shirts we labeled as X. The cost per pants, we can find that $20 times the number of pants. And now we're going to have this less than or equal to total cost, 200, or total budget. In order to graph this, we've got to look at, well, what would we do in this case when it was equal to last semester? We would find the x-intercept and the y-intercept. And the x-intercept is number comma 0, so put a 0 in for the y. So if 25x equals 200, that means your x-intercept is going to be, and then y-intercept, 0 comma number, put a 0 in for the x-coordinate, covers up that term, and we're left with 20y equals 200. We're also going to label. Let's label our graph. So our x-axis was the number of shirts. If I want to be below budget, all this below this line works. All this. So to answer the question about like if Rachel buys 5 pants, if I want to use this graph, I make sure I look at the number of pants axis, count up 5. Am I at 5 yet? 1, 2, 3, 4, 5. And then I'm just going to go over to see like what's the maximum amount, what's that boundary at. And that's how we can figure out it's a 4. So we can get 4 shirts.